There it is. Home. Rich and diverse beyond our wildest dreams. Our planet gives us everything we need. Earth is a storehouse of resources. That can sustain itself and everything on it, if we work in concert with it and understand its strengths and limitations. Rare and beautiful, Earth is at a crossroads. The choices we make today and the energy mix we pursue in the coming years have never been more critical. We know, for example, that uranium enables us to generate electricity. But how do we use this remarkable metal without harming the environment or ourselves? The answer is we act wisely. We look carefully at our energy needs, now and in the future, and implement clean energy solutions. The resources are here. It's how we use them that makes the difference. So where are we now when it comes to generating electricity? Our world uses electrical power in massive and continuous quantities. Large electrical grids feed all manner of residential, commercial, and industrial needs. As populations grow and global development continues, demand for electrical generation will also rise, predicted to double worldwide in 50 years. But when we burn fossil fuels like coal or oil to create energy, we release billions of tons of emissions into the air. Coal-fired electrical plants, for example, burn thousands of train cars of coal, choking our atmosphere. This presents a danger, especially in countries like China and India, where, if their rapid growth is fed primarily by fossil fuels, pollution levels will rise dramatically. Renewable energy sources like wind, solar, marine, and geothermal are vital and should be encouraged. But right now are limited in their capacity to produce the large amounts of power needed. Energy efficiency and conservation are also wise, and we've made headway here. But what else can be done? How do we generate electricity to satisfy world demand in a responsible way? We need powerful electricity sources, but burning things to create energy is problematic. That's where nuclear energy has an advantage. It's safe, reliable, and emits no pollutants into the air. After years of quiet service, nuclear energy is on center stage. In fact, the industry is experiencing worldwide growth that many are calling a nuclear renaissance. And the term fits. The industry is transforming itself, the way it produces power, and clarifying misconceptions. Advancements in technology include improvements in reactor designs, components, and performance, and sophisticated safety, security, and waste reprocessing systems. Each new generation of reactor is more efficient, cheaper, and safer. China is developing an advanced reactor using pebble bed technology, which virtually eliminates a meltdown situation. Basically, the reactor goes to sleep when temperatures get too hot. General Electric has developed technology that helps operators run plants more efficiently. It says the advanced boiling water reactor can be built in only 4 years and can run cheaply and safely for decades. Reactor safety and waste disposal are key concerns for people, and the industry has made strides here. Waste disposal has advanced through safer storage, better decontamination and decommissioning methods, and reprocessing spent fuel for reuse. Nuclear plants use a series of physical barriers to contain radioactive material. Everything is encased. In today's water-cooled reactors, the first barrier is the fuel itself, solid ceramic uranium pellets. Most of the radioactive byproducts of the fission process remain in the pellets, which are sealed in zirconium alloy rods. These fuel rods are in a large steel reactor vessel with walls 8 inches thick. The vessel is surrounded by 3 feet of concrete shielding. At most plants, a leak-tight steel liner covers the inside of the containment building, which is itself a massive reinforced concrete structure with walls 4 feet thick. So where does nuclear power fit in today's energy mix? Currently, nuclear energy provides about 16% of the world's electricity, coal about 41%, oil and gas roughly 25%, hydro about 3%, and renewable energies about 15%, most coming from biomass like wood burning. Over 30 countries operate 442 reactors. By 2025, this number could rise to over 600. India, China, South Korea, and Russia see nuclear energy as a way to create the vast amounts of electricity they need, safely and reliably. Right now, France, the United States, and Japan operate half the world's nuclear plants. France is literally a powerhouse, with 60 reactors providing about 80% of its electrical needs. Just over 100 reactors produce a fifth of America's needs, while Japan's 55 reactors provide roughly a third of its electrical power. Canada's 20 reactors contribute about 1/6 of its energy. Over half of Ontario's power, for example, is nuclear-based. In the U.S., it represents 2/3 of the nation's emission-free electrical generation. By using it, utilities reduce emissions by millions of tons. There is much good news, but let's not overlook areas needing improvement. Errors have occurred in nuclear energy's history. Fortunately, problems like those at 3 Mile Island in 1979 and Chernobyl in 1986 have been rare, given the number of reactors operating full-time worldwide. Costs can be high, and the time needed to permit and build a plant can be lengthy. But low operating costs and dependability over the long term factor in its favor. On the operational side, nuclear energy is a workhorse and can generate enormous and continuous amounts of electricity. For example, an average-sized reactor can supply a city of up to 2 million residents with electricity. Now let's look at uranium and its role in generating electricity. A unique radioactive metal, uranium, is found throughout the world, including trace amounts in our food and bodies. It's about 500 times more common than gold, 35 times more common than silver. It's even found in seawater. Uranium varies in concentrations from low-grade ore found in the western United States, for example, to high-grade ore in northern Saskatchewan, Canada. Right now, Canada, Australia, and Kazakhstan produce over half the world's supply.
There are many misconceptions about uranium and radioactivity. It's not dangerous in its pellet form or its yellow cake form, but it can be dangerous as highly concentrated deposits or as spent reactor fuel. It's important to remember that we live with many forms of ionizing radiation every day, from medical and dental x-rays, TVs, microwaves, and even sunlight, but we control exposure to these. Radiation from uranium poses no real threat unless it's inhaled or ingested.
In addition to fueling reactors, uranium is essential in other fields, such as medicine, food safety, and space exploration. Unfortunately, it is also associated with weapons.
Uranium is a tremendous help to us, but it does carry with it a history of warfare. Fortunately, in many countries, they're decommissioning these warheads and recycling the material for use in nuclear reactors to generate electricity.
So how does uranium produce electrical power? During fission, the metal's nucleus splits and releases energy. A controlled chain reaction occurs, generating even more power. How much? A pellet of enriched uranium is equal to over 1,700 pounds of coal. 1 pound of yellow cake, which is concentrated uranium, is equal to about 12 pellets, or 10 tons of coal. Here's a look at the uranium cycle, from mining and processing to enrichment, fuel, and waste management. Uranium is mined in 3 ways: open pit, underground, and in situ recovery, or ISR. In open pit, the ore is excavated from a surface operation. Underground mining can take place shallow or deep within the earth, where the ore is brought to the surface. The recovered ore is then sent to a milling facility, where it is crushed and processed for solution extraction in a contained and controlled environment. With in situ recovery, or ISR, in North America, water and a solution similar to carbonated water are injected into the ground to dissolve the uranium, which is highly soluble. The slurry is pumped to the surface through recovery wells and processed.
When performed correctly, ISR has low environmental impact and is the preferred method of uranium mining. For example, pump water is recharged with carbonated water and recycled several times with little water loss, which reduces the water needs. When the ISR mining process is completed, the groundwater quality can easily be restored to its original class of use or baseline conditions.
Ultimately, the uranium is concentrated and dried into a powder called yellow cake. The yellow cake is shipped to a conversion plant to become uranium hexafluoride gas, enriched to fuel-grade material, converted back to powder, and pressed into pellets. The pellets are inserted into rods assembled in fuel bundles. Several hundred bundles make up a reactor's core. In the core, fission occurs and creates heat, which boils water and produces steam. The steam drives a turbine that in turn powers a generator, supplying grids and cities and towns with electricity. Spent fuel is radioactive and requires long-term care. Storage in deep underground repositories is one method used. Another is storage of spent fuel at reactor sites in large internal water containers for cooling and monitoring. Reprocessing is an option that helps reduce quantities. The fuel is separated into its components and recycled. Scientists continue to study ways to improve this final and important part of the uranium cycle. Now let's explore some key issues in uranium mining. Although many strides have been made, mining by its nature is disruptive. But this doesn't mean its environmental impact can't be minimized. Prevention is key. By being smart at the front end of a project and throughout, many problems can be avoided. Progressive mining companies understand this.
Today, uranium mining is state-of-the-art, computerized, and more environmentally aware. For example, ISR is high-tech. The newer mines use internal and external monitoring for water and air sampling. This real-time detection helps notify operators of malfunctions in air, water, and health and safety issues. I wish I could say uranium mining has a spotless history, but it hasn't. However, the industry has progressed. Newer methods and technologies, stricter regulations, driven in part by environmental groups, and a commitment to sustainability have all worked to improve the uranium industry.
But achieving this hasn't been easy. Over the years, hard lessons have been learned. In the 1950s to the 70s, for example, uranium mining in the western United States left serious legacy issues.
At that time, the U.S. did not have effective laws or regulations in place to address worker health or environmental impact. Today, advancements in regulation, monitoring, ventilation, and worker training help in preventing radon exposure.
Radiation is also a key concern.
Uranium mining companies now operate with minimal radiation exposure to employees, the public, and the environment. In fact, companies often voluntarily adopt international radiation exposure limits long before they become final regulation.
Today, the uranium cycle, from mining to nuclear power, is one of the most heavily regulated industries in the world.
In the U.S., for example, the Nuclear Regulatory Commission, the Environmental Protection Agency, and other state and federal agencies work to ensure that uranium mining is safe for workers, the public, and the environment.
So how is uranium mining minimizing its footprint? Let's look at 4 areas: earth, water, air, and human health. Earth, protecting the landscape, including plants, wildlife, livestock, and feed, is critical.
Mine tailings and waste rock issues are heavily regulated. These items are addressed through management of specialized containment facilities, dry stacking, and backfilling of waste into existing mines. Remediation and waste handling is mandated by all levels of government and often occurs throughout the life of mine.
Water. It is imperative that radioactivity and contaminants from tailings and waste do not seep into surface or groundwater, and runoff is contained and monitored.
Water management helps prevent leaks and contamination associated with tailings ponds, covers and linings, and water collection systems. During ISR, water quality and pumping operations are highly regulated, and they're monitored to continuously evaluate water quality and impacts. Modern hydraulic balancing techniques are able to control water flow horizontally and vertically, both inside and outside the mined area.
Air. Controlling tailings dust and emissions like radon gas is critical.
Radon is a naturally occurring radioactive gas, sometimes released during mining and processing. It can be dangerous in enclosed areas like mine shafts. but it is effectively controlled through ventilation. Through efficient engineering and operations, carbon monoxide and nitrous oxide emissions are reduced.
And finally, human health. Over the years, the mining industry as a whole has improved worker health and safety.
International radiation monitoring regulations have resulted in improved equipment and worker safety through enhanced personal protective equipment and training.
Uranium mining is also more community-focused. Towns and villages near operations can benefit through employment and training and from economic and infrastructure development.
Open community meetings and forums make for successful projects, where stakeholders of varying interests can voice their opinions and ideas.
So let's recap. We know that burning fossil fuels contributes to air pollution, and that nuclear energy offers a cleaner alternative. We understand that nuclear energy and uranium mining have had safety issues in the past, but today benefit from much improved, high operating standards. And we see new technology emerging, and people working together to create even greater innovation. Nuclear energy gives us a practical, emission-free advantage when we need it most. France, the US, Japan, these countries have benefited from it for years. Let's not let outdated fears or misconceptions keep us from tapping into its power.
Nuclear energy provides us with electricity on a large scale that can meet both local and global energy demands for generations, fueled safely by one of the most unique and abundant resources on the planet, uranium.
It's time to clear the air. Uranium, nuclear energy, and the power of human ingenuity are coming together to help fuel the future, creating an increasingly important energy source that is both powerful and sustainable for years to come.